Hello everyone, welcome to OpenAM or ForgeRock Access Managers overview. So, in this particular session, we are going to have a basic understanding of access management on the first place, and then we'll be describing what are the common access manager components, as well as we'll be describing how we can locate the access manager's resource in the ForgeRock Backstage website. So let's talk about basic access management first. As you know that access manager provides access management which consists of two parts. One is authentication and other one is authorization. So authentication is basically about who the user is who is trying to access the resource, and authorization is what the user actually can do on the resource. So basically it's all about resource protection. Resource mean to say in an organization are the application, web application, Java application, different kind of application that a user can use to perform their daily business tasks. The user's scope over here can be they can be a customer, they can be an employee, they can be a contractor, they can be a subscriber. So there are multiple definitions of users in a particular organization, and on basis of those definitions, uh, how the users are going to authenticate themselves or determine or access manager determines who the user is by different mechanism that part come under authentication, and also how the manager decides whether or not to provide the access to that particular user for that particular resource. So AM actually manages access to the resource such as web page, an application, or a web service available over a network. So once it is set up, AM provides an infrastructure for managing users, roles, and access to the resources. So let's see a typical use case why it is required in the first place. So just for an example, just suppose the company we are taking an example over here is XYZ Corp. So XYZ Corp has around hundreds of applications uh, um, built for their enterprise, which users can use, and the users have a wide range. Like users can be customers, users can be employee and contractors. So your XYZ Corp have multiple applications, and the thing is, an application to perform to have a security management in itself required always required three things. One is your authentication, another one is your authorization, and the last one is provisioning. So authentication means so suppose if we take an example of app 1, so app 1 might have a way of knowing who the user is. So whenever a user is trying to access app 1 using a browser, app 1 must throw some sort of challenge to that particular user uh, that will define who the user is, like an HTML form which will have two fields, username and password, and user will fill in that particular form, username and password, and then app one uh, uh, will verify that combination of data against a service which contains the information about that data. So that service over here can be considered as directory service. So, and the directory service will be containing the authentication data. So your app one has to first of all manage a backend directory service or a data or a backend or a database which contains the authentication data. And app one must also implement the uh, the challenge module, which will define how the user are going to pass on the information about their credentials to app one. So these two things comes under the part of authentication. So these things has to be implemented for app one. Next, app one has to decide whether or not this particular user should be able to access It's resources. So resources can be in a bunch, like app one want all the resources to be used by an authenticated user, or we can app one can choose to decide what part of the resource can be accessed by the user. So there is a differentiation in the user, like there will be a normal user who needs access to the basic home pages, or some of the basic functionality to perform their day-to-day tasks. But there is another type of user which is admin, which will require elevated access in that particular application to perform their daily business. So in that case, app one has to define a way to determine whether or not this particular user should be able to access this a specific resource within app one. So if we start defining, this is the challenge, and this is the backend, and then this is the authorization service, or yes. So this is the authorization service. So these things has to be implemented within an organization, within an application. Simply, another module will have to be implemented, which will determine the uh, how the resources are populated in the backend. So that particular module is known as provisioning. So the app one can decide how the users are created at their backend. Before the user is trying to access the resource must have an information about the users beforehand, right? So there are multiple ways of implementing that kind of functionality, like app one can enable the user registration so that user can directly register themselves, give their username, passwords, give their username, select their password, choose their passwords. After that, they can choose certain security settings at the start, and they can give the contact information like email address and all, how application will be able to notify the users for any kind of changes. So all these kind of initial attributes should be provided to the user. So this kind of this kind of module which will directly impart the knowledge to the app one regarding the user at the very first place is also required, that is called as provisioning. So this is a way to create uh, uh, the users from app one to the business to the backend. So this particular implementation of the modules makes application one very heavy. Okay, why? Because they have apart from the functionality they are providing, they have to implement these kind of security functionalities as well. Now, the thing is, since your corporation have multiple applications, suppose there are 100 application, all of these should be implemented in each and every application underlying. So you should have a challenge mechanism, you should have a backend, you should have a method of provisioning those users, you should have a authorization service as well. So all these things uh, will means if that these things these four modules are implemented for each and every application, the cost of maintenance and implementation becomes very heavy for an organization. Also, the thing is, uh, the user experience will also not be very good, because users must register their account in each of those application. Suppose there are 100 applications, they have to register their account 100 times. Then they have to remember the username and password every time, for every kind of application. So suppose there are 100 application, there will have 100 application. A user will have 100 application if he is allowed to access all these 100 application. So that is a kind of cumbersome process for a particular organization. It imparts higher cost and higher cost of implementing a security module. Also, it's not a good experience in terms of a developer. So application developers have to implement all these things on their own form for a particular application. So that again increases the cost of implementation as well as maintenance for uh, a corporation, for an enterprise. So to reduce this kind of requirement, we can actually centralize all of these three mechanisms into one. So how we can do that is, first of all, if we uh, uh, so so these four modules we need to be implemented. So suppose there is a way which you can centralize the authentication backend. So your backend can be centralized where all of your application will be connected at the backend. Okay, and they will have same authentication data. That means the first challenge, that is the user experience, is uh, is like the user experience is resolved, because the user has to remember only one set of credential, and so and all of the application are using the same set of credential at the back end. uh, Hence the user need not to remember hundreds of credential. Instead, they just need to remember only one credential, and they are able to log into all of these different application. So that is what backend is all about. So here in ForgeRock, the backend can be implemented using OpenDJ. So in the previous session, we have seen in OpenDJ how we can utilize OpenDJ as a backend, uh, going on toe to toe with the widely used the LDAP service, which is Active Directory and OID. So you can utilize OpenDJ for a specific backend for all of the application. It has that kind of load capability, which can hold the data of multiple million users, and can provide the data with higher latency to the applications that are emitted in your organization. So your backend part is resolved. Then the second thing comes is how we are asking for the user for their credentials. So that part also can be centralized, because even if all of the application are connected with the same backend, the users still have to log in multiple times. If they want to access an application, they have to log in to that particular application using the same set of credential, but they have to log in again and again for each and every application if the application is defining the other modules by themselves. Each of these modules can be defined for a specific application independently as well, as you know. Now, for that, we can use a centralized authentication module as well, which can provide this kind of challenge and can manage the user session at a centralized place. So, in that case, your OpenAM comes into picture. OpenAM actually can provide a way of challenging the user to define their credentials. So there are multiple modules that are implemented for Access Manager OpenAM, which can decide how user is going to identify themselves. So there are form-based authentication mechanism. There are risk-based authentication mechanism. There are your OTP-based authentication mechanism, radius-based authentication mechanism. So there are multiple authentication mechanism that can be provided by Access Manager to the user, and user can verify their identity in all these multiple methods. So this is one part where the authentication is implemented under OpenAM. Now the next thing is OpenAM can also be utilized to perform authorization. So it can determine whether or not the user who is already authenticated will be able to access this particular application on the basis of the different kind of attributes that is available for that particular user. Once the authorization part is done, so you will have a fully centralized mechanism of of getting the user's authentication data and also getting the user's authorization data. So these two things can be implemented at a centralized place when if we have implemented OpenAM as our centralized access manager. Now, the only thing is once we have implemented these modules, the only thing is to connect all the application with your access manager as well as your OpenDJ at the back end. So there are different ways of implementing that kind of scenario. Um the thing is, the backend is not always required to be connected with your application, since the authentication is managed by the by OpenAM. So you can directly connect OpenAM with the backend, and it can provide the authentication data to App2. So App2 does not have to application does not have to worry about authentication backend, authorization, and all these things. So you can connect hundreds and hundreds of application with your OpenAM to define a single point of authentication as well as authorization. Now, OpenAM can also implement provisioning, a slight feature of provisioning, means a small feature of provisioning which can enable the users to register their account into your OpenAM. Once the user account is created on OpenAM by user registration, that account will be passed on to the backend. So your account will be available in OpenDJ as well. So this way, a new user can gain access to an application on the on the basis of their credentials. Now the thing is, this particular module is not as fully fledged and cannot be considered inside identity management, because identity management is way more than that. It takes care of how your identities are created and how your identities are disabled in an organization and all these things. So for that, ForgeRock have another product which is OpenIDM, which is which actually take cares of that particular functionality. But a slight functionality we can be given to the user so that they can actually create their account for having a ready access for their particular application, for to have at least a basic level of access for that particular applications. So that kind of independence is given in OpenAM as well, so that they can provision the account. Administrator can also create the accounts of the user that should be uh, that should be accessing that particular application. Okay, this so your provisioning part is also uh, can be slightly implemented in your OpenAM. So you can see all of these modules are now centralized. Now the only thing is to connect all the application with your OpenAM. So for this kind of connection, we can utilize different ways how an application can be connected to an access manager. So there are multiple types of application out there. If an enterprise is implementing any kind of application, the applications can be of various types. So the most basic type of application is a web application, uh, which is deployed in a client-side scripting language, which can run on a web app server like Apache Web Server or IIS. So there are different kind of servers that can expose a website, uh, a simple website built on HTML5, JavaScript, CSS. So these kind of client-side scripting languages, jQuery, uh, and all. So this particular type of application only required to be deployed on a web server. So you need to connect that particular application via the web server to Access Manager. So the Access Manager provides a module which can be considered as an agent. Now in this case, it will be web agent so web agent will be the person, or will be a guardian for that particular application, which will intercept all of the communication going in for that particular for going in for accessing all that particular application, and it will intercept it, uh, checks for the authentication of the user, if whether or not the browser has a specific type of information available with them that can allow the user or a browser to access the resource. If they do not have, then in that case the browser will be redirected to access manager for the basic authentication and authorization. Once the results are returned from the access manager, the the web agent will return the user to the particular resource. Now, on the basis of the result coming in from the access manager, whether or not the user can access that particular resource. So web agent can act as a gatekeeper who can determine whether or not the user should be able to access the resource. So that particular gatekeeper will do that with the help of your access manager. Everything will be centralized. How the gatekeeper will behave, how it should intercept, and what kind of resources they want to protect in a particular web app. So all these definition can be defined centrally at access managers end, and web agent will follow that particular mechanism how it is defined inside access manager. So only the connection has to be made via web agent. So web agent is connected to am, web agent is connected to the web server. So this way your application is also connected to your web so to your access manager. So this is the connection between your web app and a access manager. So similarly, we may have an application which is developed in Java or any kind of server-side scripting language. Server-side scripting language like PHP, you can say Java, .NET. So these kind of these kind of applications actually involve much higher complexity. So in that case, there is another type of agent that is available. So this another type of agent only works along with the Java. So we can create two different separate specification of these kind of application which are developed in server side languages. One is only with Java. So an application developed in Java and is deployed in a application server like Tomcat, WebSphere, WebLogic. So that kind of application can be protected by implementing an another agent which is known as the Java agent. So Java agent will perform the same functionality what a web agent will perform. It will protect the resources, the servlets that are present in a particular application, and can enforce policy checks for specific type of resource access. So the communication between AM and the Java agent is same as the communication with web agent and access manager. So only the connection if you want to make, you need to implement a Java agent within the server which is holding the Java application. Now, if the application is developed in a server-side language but is not in the native libraries of your OpenAM, then in that case you can implement a basic web agent again, which can protect these particular resources along with reverse proxy that will actually uh, 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 divert the traffic uh, divert the traffic that is coming into the application to the web agent. So instead of sending the traffic to the web to the application, it will send the traffic to the web agent so that web agent can take the decision of authorization as well as authentication on behalf of the application. So these are multiple types of architecture that can be followed in an organization for such kind of implementations. So just need to implement this way for these kind of applications. So the thing is basically web agent or any kind of agent's responsibility is to intercept the traffic coming in to access that particular resource. Then after that, it should enforce a specific policy on that particular traffic. It should it should perform certain set of validation with the help of access manager. So if the traffic is coming in for accessing that particular web agent, it will look for certain headers, for certain cookies that should be present for that particular in that particular traffic. If that is not available, the web agent will redirect the browser to the access manager where the policy validation happens. So first the authentication will happen, the user will authenticate with access manager. After that, the policies will be checked whether or not the users can access that particular application. And then once all these checks are validated and confirmed, then access manager will create the headers or those cookies or those information that is required by the web agent to allow the browser to access the resource. So that that particular uh, information can be persistent or can be stateless, like it can be sent on the form of headers, it can be sent in the form of cookies. So cookies will be sent directly to the browser, and browser will present that cookie to the web agent, and web agent will determine whether or not that cookie is valid. And once the cookie is valid, the web agent will allow the user to access the particular resource. So all of these things has to be implemented by a web agent. If web agent is not able, the agent is not able to implement the redirection part, then in that case you can place that behind a reverse proxy, which will redirect the traffic. Uh, in case a specific cookie is not present, it will redirect the traffic to the web agent, and then will the all other steps will be implemented sequentially. Now there is another kind of application which is like which comes into picture as capable of implementing its own security. Security is already implemented for them, but they still want to embed with the centralized access manager server. So that kind of application are developed in any kind of server-side language like Java and PHP, .NET, but they support the basic standards of federation. So it can communicate to an access manager using the basic standards available in the market like SAML, like OpenID Connect, OAuth. So these kind of application can be connected to the access manager directly by using those standards. So access manager supports your SAML implementation, it supports your OpenID Connect implementation. So it supports the federation on the basis of the readily available standards in the market. So all these type of application can directly be connected to your access manager. So this kind of implementation can save a lot of cost. You need to manage the authentication data at one single point, and you need to manage the access management modules at one single point by your access manager. So that's about the overview, why access management is required, how it is implemented in OpenAM. So that's all about this particular session. See you in the next session. Thanks a lot.